runs off of engines, but for the most part, we still use the same ones we invented a long time ago. Steam turbines were first introduced by the engineer Charles Parsons in 1884, and really, they're still the standard. Designs do differ, but they generally work via the burning of fossil fuels, which evaporates water, which builds pressurized steam, which builds up and up in an enclosed system until it pushes the blades of a turbine. In doing so, heat is transformed into mechanical energy, which can then be used for electricity, etc. But despite their historic success, steam turbines aren't without problems. On average, they transform only about 35%, at most 60%, of the total heat energy they're subjected to into electricity. The rest is lost, making them very inefficient. One of the base problems with steam turbines is that they themselves have many moving parts, meaning a long list of stages and drop-off points from the start to the finish of the process. The many moving parts limit the temperatures that the steam engines can handle too, because each part can only take so much heat before warping. And this is a major issue, considering an engine's entire purpose is to transform heat energy. Steam turbines are inevitably physically limited. As such, contemporary research has instead grown around what are known as solid-state engines. Solid-state engines have no moving parts, which is then a potentially huge benefit. In 2022, researchers from MIT and the National Renewable Energy Laboratory in the US published a study in the journal Nature detailing fresh experiments with a new type of solid-state engine. From the very beginning, reports were that it averages at a 40% energy transfer rate, which is already better than most steam turbines, although all hopes are that its eventual performance will far, far exceed even that. The new engines run via a tweak on an emerging technology called a thermal photovoltaic cell, or TPV cell. A TPV cell functions similarly to how solar panel cells or photovoltaic cells work. They take photons, i.e. energy, from, say, the sun, and turn those base particles into electricity. What's especially great about TPV cells, however, is that they can operate at temperatures much higher than what's possible with a steam turbine, meaning more heat and energy and power passes through them from the outset. More than that, though, TPVs can be used to store wholly renewable energy as well. This is perhaps the most revolutionary part of them. According to the study, and others since, by attaching TPV cells to a thermal battery, heat energy can be held indefinitely and later turned into electricity by the same TPV cell. This means that even when the sun isn't shining, or perhaps in another setup the wind isn't blowing, TPV engines, backed up by thermal batteries, should continue to run and run entirely unobstructed. Thermal batteries aren't a new technology, but their use in this way is still innovative, as is the setup of the TPV engine itself. In short, the team behind it placed a thin gold sheet underneath the TPV cell to act as a mirror. The mirror then reflects any passing but missed photons back into the cell to be reabsorbed again and again, which then increases the efficiency of the wider engine, ensuring that less is lost. But it's hoped that the design can be made to be even more efficient still. Previous research in 2020 revealed a specific material that can, under the right conditions, reflect back up to 99% of photons that reach it, much more than the standard gold sheet. And so if that material can be merged with this TPV technology, then we could be on the brink of another major uptick in the engine's performance. It's already impressive, but it could soon be even more so. Add into the equation that this new kind of solid-state setup has generally lower maintenance cost projections too, and it's easy to see why it could have a big impact on the energy sector. According to one of the lead researchers, Professor Oshagun Henry, TPV cells were, quote, the last key step toward demonstrating that thermal batteries are a viable concept, end quote. Before, despite their promise, the practical applications for thermal batteries appeared to be limited, but not with TPV cells bridging the gap. The possibilities open out and out. At the top of the scale, there are early talks of redesigned whole power plants, not just smaller individual facilities, but entire socially and economically crucial energy bases. At present, most major power plants are in some way dependent on fossil fuels to provide their energy. But fossil fuels are, of course, non-renewable and destructive to the environment. Incorporate TPV engines, however, and all plants could soon be humming along on the reliability of stored renewable energy instead. At least that's one potential and exciting direction in which the team behind this new engine believes we could soon be headed. Especially as it's also hoped that this new technology shouldn't be overly difficult to manufacture on a large scale either. As TPV cells are fundamentally similar to solar cells, and as we already have a growing number of factories to make those, a lot of the early legwork has already been completed. On the face of it, this wouldn't require a total reinvention or a radically new process. It would only need some slight tweaks here and there. If TPV engines are successfully implemented into modern life then, what happens next? What kinds of differences could they realistically make? Again, Professor Henry is optimistic. In an accompanying MIT article for the original study, he says that, quote, "The technology is safe, environmentally benign in its life cycle, and it can have a tremendous impact on abating carbon dioxide emissions from electricity production," end quote. For those on the outside looking in then, could this finally be the missing piece needed to properly move away from limited and damaging fossil fuels? Could this finally be the technology to convince the rest of the world that renewables aren't only a better idea, but that they're feasible and capable of meeting our needs as well? What might the future look like? In the best-case scenario, perhaps we'll see thermal battery-powered TPV engines that are actually powerful enough to provide energy for whole streets, towns, or communities. Or perhaps TPV vehicles that never need to be filled up, but instead are kept running based on wholly natural means, like the sun's light, but also the winds and perhaps the tides of Earth, too. At present, and even with renewable energy, there's often a major midpoint through which all energy passes as a commodity from provider to consumer. But with TPV, perhaps that midpoint will itself be bypassed as well? If nothing else, then the prospect of an engine and battery that can store and use energy indefinitely means that beyond the manufacture of the actual engine, users should be much less reliant on bigger companies for their energy needs. Quickly, energy bills could be a thing of the past, with an engine that's at once relatively easy to make, simple to scale up, reasonably low cost to maintain, and limitless in terms of its energy potential. That said, converting an entire planet's entrenched energy structure is no mean feat. Redirecting an entire civilization's long-held energy habits is more easily said than done. And perhaps there are yet technical reasons as to why we aren't already all enjoying the benefits of TPV engines. What's your verdict? Is this technology the holy grail for our collective energy needs? Are there other reasons as to why it hasn't been more widely pursued before now? Is the energy sector perhaps unwilling to change, or is there actually still just a long way to go before TPV properly takes off? Let us know your thoughts in the comments. But for now, though, we are at something of a crossroads for the issue. Fossil fuels have to be replaced, renewables need to be able to do the job. One thing that is clear is that TPV cells plus thermal batteries could be another vital step towards a new, improved, and limitless tomorrow. A tomorrow that we're getting closer and closer to realizing. And that's how scientists may have already invented